Hey, it's Mr. Han here. Here are our notes on naming algebra tiles. So today we're going to be spending time on looking at these tiles right here and technically finding the area of each one. Right now it looks like a lot of just random shapes with different colors, but we're going to understand these very well this year. So make sure you're paying attention, and then we'll get into how to find the area. So this first one we're going to look at is this blue, navy blue one here. I'm going to pull one up on the screen. You can see right here it's very small. Okay, so if we ever use these in class, all right, these are unit tiles. So right here, I'm going to well, first let's start with the description. So what's the description of this, right? How do we describe this very small unit tile? Okay, we are going to go ahead and say that it is a small navy blue tile. So small navy blue square. Okay. So here we have a small navy blue square, and I'm going to go in and zoom in, and I'm going to tell you that the distance right here is 1, and this right here is 1. Okay. So I'm going to go ahead and erase the little curved lines and say that this is a 1 by 1. So if I told you that the distance here is 1 and the distance here is 1, we can go ahead and find the area of that tile. So right here on the right side, we're going to name the tile, and we're going to name it by its area. So the area of this unit tile, right, of this small blue navy blue, the small navy blue square tile, okay, it's going to be base times height, which is 1 times 1, which equals 1. So the name of this tile is going to be a unit, right? 1 unit, a unit tile, right? Unit. Let me get rid of this. Let's say unit tile. Okay. So we're going to call this a unit tile because it's 1 times 1. So that's the very basics. Okay, so that's this one right here. The next one we're going to talk about is this blue one. I'm going to pull it up on the screen right here. Okay, this blue one is, well, how would you describe this? Let's go ahead and find that color, like sky blue. So this is sky blue rectangle. This is a rectangle in the color sky blue. So that's how I'm going to describe it, a small sky blue. Oh, let me call it small. Let's move this just down. Move this whole thing down a little bit. And call it a small sky blue rectangle. So here, the distance right here is 1. But what I'm going to do right now is I'm going to pull this up on the screen. Okay, so take a look at my face. All right, and I'm going to line these up so that they are flush. Okay, and if this right here is 1 unit, we have 1, 2, 3, 4, 5. So this is a total of 5. How long would you call this X tile? Oh, how long would you call this sky blue rectangle? What's the length or the base, right? What's the base of this? Can you tell me what the distance is, right? I know my fat finger's in the way. Let me see if I could do this. Nope, I can't. So I'm gonna have to hold it right here. So you know that it's flush already, okay? So I'm holding it on this end, making sure that it is at the same, starting together. How long would you say that this is right here? 1, 2, 3, 4. But look, it doesn't reach 4, right? So we could say that it's like 3.5. Do you see? Oh, do you see what I'm saying? Oh, here, let me use this pen. 1, 2, 3, and like a half, right? We don't know. So because we don't know, we're going to call it X, okay? So we're going to call this x. This distance right here. X. Okay? So this is an x by 1. So the area here is 1 times x. And I don't like that I used a multiplication sign for x, so I'm going to use a dot. 1 times x, and that equals x. So we're going to call this an x tile. Okay? So just an overview right now. We are naming these tiles. We're going to be using these tiles throughout the school year. Okay? The point for what I just tried to show you, I can't find the x tile. I lost it. Let me see if I could just grab another one. Where did I put it? Did I eat it? Who knows? All right, so I'm gonna just pull it out of here. I have a whole bunch. Okay. So the point here is, if we line it up, right? We do not know the actual distance. I'm not going to sit here and say that this is exactly 3.5. I don't know. And the point is that we don't know. And when we don't know this value, right, we're going to call it x. We don't know. And just for the purposes of, for the future, right, x, I know it looks like it's in between 3 and 4, right? It looks like it, but I can't create a physical tile that is 1,000,000 or 1,000, right? So I'm going to use this unknown x as a number that I just don't know. And that number can mean anything. And we'll get to that later. But here, we're going to do the same thing here. So I'm going to pull up this purple one. This next one's this purple one. What would we call this right here, right? This would be a small purple rectangle. So right here we have a small purple rectangle, okay? And here, we'll do the same exact thing. I'm gonna line up this guy and put him flush to him, right there, okay? If I add one more, you can see, oh, this is horrible that I'm doing in the air, but you can see that it doesn't line up perfectly. So it's not 5, but it's also not 6. It's in between 5 and 6. So here's another example of a tile where we don't know the exact length. And when we don't know the exact length, right, we're going to have to give it a variable. So I'm going to call this distance 1. And just so you know, I could go ahead and put one of these tiles and line it up right next to it. It's the same height, right? It's the same height. Let's see, yeah. It's the same height. But the base is a little bit unclear. So the height is 1, but the base here, we'll call it y. Y is another variable, right? We don't know what the value is, so that's what we're going to call it, y. So the area here, 1 times y. And 1 times y is y. So here we're going to call this the y tile. Okay. Remember, the point of this lesson is to name these tiles, and that's what we're doing right now. We're giving these tiles a name, and we're going to be using these tiles throughout the school year. So make sure you're really focused, okay? And hopefully these colors will help you as we move along. So far we have a unit tile. That's right here. Unit tile. Then we have an X tile right here. And now we have a Y tile. So those are the main ones that we're going to be referring to, okay? And now that we know that this distance right here is Y, and I'm telling you right now, that's what we're going to call it, okay? Because we don't know what it is, and Y is a variable. Technically, I can use any letter as a variable. I can use P, I can use M, I can use I can use S, I can use anything, any letter, okay? But I'm using X and Y because those are the main variables we use in math. All right. So now that we have the main variables in here, we're going to go ahead and look at these next ones. Okay. These next ones, colors hopefully will help you. Okay. The distance here, and And I don't think I'm using the right color. I am not, so we'll go ahead and change that back. There you go. This right here is X. And what I can do to just prove it to you, I know that this line is the same color, but I'm gonna go ahead and draw a line right there and move this over just to show you that the distance is the same. Okay? And I'm telling you that this is the same. So here's X, and here is also X. So, oh, we forgot to describe this. This is going to be a large sky blue sky blue square. Okay. And how do we find the area of this large sky blue square? Well, how do you find the area of a square? Right? It's going to be base times height. So base is X, height is X, so it's going to be X times X, and that equals X squared. If you don't know what this little 2 is, it's an exponent. And whenever we have a number times itself, an exponent is saying that this X is going to be multiplied by itself twice. Okay? So the area here is X squared. We're going to call this an X square tile. Okay? So we have a unit tile, X tile, Y tile, and then an X squared tile. What do you think this next one's going to be? What do you think this next one's going to be? So I'm going to tell you right now that this distance, oh, I keep using the wrong purple. This distance right here is Y, and this distance right here is also Y. Oh, not a calculator. Ah, sorry. Get out of the way. There you go. We didn't describe this, of course. This is a large purple square. So how do you find the area of a square? It's going to be base times height. So the area here equals base, which is Y, and height, which is Y. So area equals Y times Y, which equals Y squared. So we're going to call this the Y squared tile. All right. So hopefully this is making sense so far. We're naming all of these. This last one we're going to name, you don't know, but I wish I had a way to take this distance. Oh, I do. You can go ahead and draw a line right here. You can't see it. I'm making it super big, super long. Okay, it's not working, so I'm gonna draw it again. I drew a line. I just drew right now. I'm going to show you that this distance right here is Y. Bring this down. The distance on the bottom is right here. Y. Oh, I've not been bringing these tiles up. So that's this one right here. Okay? We'll draw a line for this X. We'll move it down here. Oh boy, I did not draw these to scale. Horrible. So the base is Y. I'm going to pull up the Y tile and line it up. You see that's perfectly aligned. Can you see that? Yeah? So the base is Y. The height is actually the same size as the X tile. Let's see if I can line that up and show you. Okay, so this green one, the height is X and the base is Y. And to describe this, we're going to call it a large green rectangle. And to find the area of a rectangle is base times height. So we're going to do Y times X, which equals YX. So we're going to call this a y, y, x tile. Okay? Or I'm going to actually call it an xy because in the alphabet x comes first. And that's why I'm deciding to call it xy instead of yx. So right here so far in the notes, we've named these tiles. This is one of the main things I want to do in these notes. And so now that we name these notes, I want you to recognize how. How did we name them, right? How did we name them? We named them by finding the area, okay? So the area of all of these shapes give it its name. So this unit tile is 1 by 1, so it's 1 unit. 1 times x, which is x. 1 times y, which is y. X times x, which is x squared. Y times y, which is y squared. And x times y, which is xy. So that's how we got all of these names. Alright, I'm going to go ahead and box these because I did them for all the other ones. Purple. Alright, so far we've named these tiles. So, right here, I want you to go ahead and name all these tiles. Oh, well, would you look at that? We already gave you a lot of them. Okay, so instead of just naming them, we're going to combine them. So today, the second part of our notes is to combine like terms after we name them. So here, I'm going to go ahead and use my highlighter. And because I remember the colors, I'm going to color these in by the way we described them, right? Sky blue for the X, squares, sky blue for the X squares. All right, so go ahead and color these in right here, depending on how we name them, right? Sky blue right here. And once we do that, we have to do it to all of them. So this is the X squares. I need to go ahead and find all the X's. I'm gonna go ahead and highlight that. Highlight that. Highlight this. Let's go ahead and do that. Coloring is somewhat therapeutic for me. I don't know why. It's like every kid just loves coloring. I love coloring. So we have all the X tiles highlighted in. And notice I'm not using the pencil, right? Right here, look at, oh, you can't see my mouse. Right here, I'm using the highlighter. Okay, and then now I'm gonna go ahead and find the navy blue. Or yeah, the navy blue. And shade these in. 1. This is 5. This is another 5. There's 1. Here's another 1. And here's another group of 5. Okay. So, I'm going to go ahead and count how many X squared tiles do I have. I've got 1 right here, 2 right here, and 3 right here. So I'm going to say X squared plus X squared plus X squared. Oops, that's X cubed squared. So I've got 1, 2, 3 of them. Okay? So I'm writing this out. I'm going to start combining. How many X squared tiles do I have? That's my question. Here, let me recap. So after I highlighted, now what I'm trying to do is I'm trying to see how many of each tile do I have. So here, I can see that I have 1 X squared tile, 2 X squared tile, and 3 X squared tiles. Okay? So I'm going to go ahead and write those out. X squared plus X squared plus X squared. All right. So we're done with those. I'm going to put a red check mark once I got them. Okay. Sweet. Now, I'm going to go ahead and say plus 1x. So I'm going to say plus x, plus x, plus x. And just so you know what I'm saying, this first one right here is this one. The second one's right here. And this third one's right here. Okay? So plus x, here I'm going to add another one. Plus x. Here's another one. So I'm going to say plus x. Here's another one. Plus x. So I should have 1, 2, 3, 4, 5, 6 x's. I should count 1, 2, 3, 4, 5, 6 x's. Do I have any more? No. Next, I have these unit tiles. I'm gonna go find my navy blue, and I have 1, 2, 3, 4, 5. So every single one of these groupings is 5. Here's another. Oops. 5. Here's another 5. All right. So I have plus 5. Plus 5, plus 5. I'm going to put red check marks on those. 1, 2, 3. And then I could go ahead and add 1 here. Plus 1, plus 1. So plus 1, plus 1, plus 1. Go ahead and mark those. 1, 2, 3. Notice I have a check mark on every single one of these shapes because they are all counted for here. All the x squares, all the x's, and then all the unit tiles. Okay? And today, the second part of our notes is to combine like terms. So what does that mean? We're asking how many x squares are there total. Here's 1, 2, 3. So I'm going to say that there are 3 x squared tiles. And hopefully you are able to recognize that. We've got 1, 2, 3 x squared tiles. All right. Next, we're going to combine all the x's. Now, I know that x and x squared can be confusing, so I'm going to take a moment right here. Look at me right here on the screen, right? Does it make sense for me to say that there's 1x and another x squared and say that there's 2 of the same thing? They're not the same, right? So I want you to clearly understand that x squared and x are different. They are not the same. I can't say that there's 2 x tiles. Is that true? No. There's an x squared and an x. I cannot say that there's 2 of them. They're different. It's like me saying that there's, let's see, what can I grab around here? Let's just grab random things. I got NBA 2K and Pokemon Sword. All right. Now, there are 2 games, I understand, but they're games for different consoles, right? There's one for PS4 and one for Nintendo Switch. Can I go ahead and say that I have 2 games that are for Xbox? No, because I have none. Can I say that I have 2 games that are for the PS4? No. I've got one for the PS4 and one for the Switch. Same thing here. Can I say that there's one for the PS4 and one for the Switch? Yes, right? Are you following me? But can I say that there's 2 games for the PS4? No. That's the concept here. They're different. They're different. I cannot say that I have 2 Xbox games or 2 PS4 games. They're different. They're not the same. So that's the same concept here. We cannot say that these x squared tiles are the same things as these x tiles. Okay? So right here, now I'm going to combine. How many x tiles do I have? How many Nintendo Switch games do I have? That's kind of the way I'm trying to teach you. There's 1, 2, 3, 4, 5, 6. So there's 6 x's, right? And I'm going to go back. I'm going to check how many x's are there. 1, 2, 3, 4, 5, 6. And it's not fair for me to go 7, 8, 9. They are not the same. Do not do that. Okay? make sure that you're counting them separately. There's 1, 2, 3 x squared tiles, and then there's 1, 2, 3, 4, 5, 6 6x tiles. Okay. Last but not least, the unit tiles. Now, it is fair for me to say that there's 5 here, 5 here, so that gets me 10, 5 here, which gets me 15, 16, 17, 18. There are 18 unit tiles, plus 18. And if I add 5 plus 5 plus 5 plus 1 plus 1 plus 1, I get 18. This is 10. This is 15 plus 1 plus 1 plus 1 equals 18. All right. So if I went ahead and added these unit tiles together, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And just so you know, those 5 unit tiles on your screen, look at me right here, it's the same thing as this 5 unit tile. It's just an easy way to count by 5. So that's why we have these. And then here's another one. So I have a total of, how many do I have on the total right? How many do I have total right here? 6. Okay. So right here, we just combined like terms. We combined all the x squares to say that there's 3x squared plus 6x plus 18. And right here, this is what we're learning today, how to combine like terms. So the first thing we did was how to name. The second thing we did was combine like terms. Okay. I'm going to go ahead and do these quickly, okay? And then I'm going to try to wrap this up. So right here, we have a unit tile. So we'll call this 1. And here's another unit tile, 1. So I'm going to say 1 plus 1 at the very end. We have 1x squared. So we have x squared plus 1x tile. So if I add these all together, can I say that there are 2 x squared tiles? No. Are there 2 x squared tiles? Do you see 2 of these? No. So please make sure that you don't combine x squared with x's. They're different. All right. So I could say that there's 1 x squared tile plus 1 x tile, but I can combine these two right here. I can combine the unit tiles and say plus 2. All right. That's combining like terms right there. We just combined what we can right here. Next one. We have an x tile plus x. 3 x tiles plus 1 plus 1 plus 1, 1 plus 1 plus 1. And here I'm going to combine the x tiles right here. So I have 3x plus 3. Okay?